Hello everyone. In this video, we will be talking about relative velocity. In relative velocity, we're considering a motion from two different perspectives, in some cases, or we're considering a vector addition due to the motion of other objects affecting our moving object in different perspectives. So for our first example, let's say we have someone walking on a train at 2 meters per second, and the train itself is moving at 50 meters per second. And let's say we have a friend that's on the train tracks waving to our friend in the train as he's walking by. Now, to the person on the train, if the person didn't know that the train was moving, to him, or to his perspective, when he's walking at 2 meters per second. But he cannot consider the motion of the train. But now, if we look outside to our friend that is waving to the person on the train, the person outside can see that the train itself is moving at 50 meters per second. But at the same time, his friend is walking in the train at 2 meters per second. So in reality, when we consider it from the perspective of his friend, he can see that his friend is actually moving at 52 meters per second because it's the velocity of the train moving and the person himself moving as well. This is one example of relative velocity where they're moving on the same axes. So let's say the person was walking in the opposite direction at 2 meters per second. Now, the person would instead be moving at 48 meters per second from the perspective of his friend. But what if it's not on the same axes? Here, let's consider a boat trying to cross a river. Let's say the boat, when it's in still water, can travel at 10 meters per second. So whenever the water is still, it can get across at 10 meters per second. But in this scenario, we know rivers flow, and the fluid pushes on the boat, giving it a velocity in this direction, upwards or down a stream. Let's say it has a velocity of 2 meters per second. Now, how does this affect the motion? Now we see that it's a motion in 2 dimensions instead of 1, where we have a y velocity, and let's consider it from the perspective of a coordinate as a negative x velocity. So this would be another example of relative motion if we're considering the perspective of someone that is looking at it from the side of the bank. Now, how do we deal with relative motion problems? All these problems are an examples of vector addition. It can be addition in the same axes, or it can be finding the resultant vector that will give you the summary of the motion. Let's look at an example problem. Now let's look at this example problem. Let's say in still water, this boat is able to move around at 2 meters per second. And that's its maximum velocity. Let's say this boat is then put into a river and is trying to cross the river to get to the other side. Now we want to make sure that the boat reaches the same point it starts at straight across the river. How can we accomplish this? So let's say if the boat tried to move in the straight direction with its max velocity across the river, would it end up at the same point? No. So as the boat is moving across, we know the river is also pushing on the boat, giving it a velocity in this direction. So the boat would end up somewhere more like here, which is not what we desire. So how can we remedy that? We must angle the boat upstream, so make it go in this direction a little bit in the x-axis. And the vector should be big enough in the x-axis so it cancels out the velocity due to the river. So what would this look like? So the velocity vector would have to look something more like this. So if the boat pushed in this direction such that the x component for this velocity would be the same as the river, but in the opposite direction, then it could have a y component that would take it straight across the river. Now, how can we find the angle at which, from this vertical line, the boat would have to travel and the velocity of the boat trying to get across the river? So we know in our little diagram, this is 2 meters per second, this is 1 meters per second, and this is the angle. And this is our y velocity. So, in this vector addition, you're mostly considering just a simple trigonometric problem. So let's first find the angle. It should be angled upwards for it to get straight across. So, since we have the opposite side and the hypotenuse, we should use sine. So we know sine theta will equal the opposite over the hypotenuse. So if we find the angle, so inverse sine of 1/2, it will be 30 degrees. Simple enough, right? So finally, let's find the y velocity, or the velocity across the river that the boat can have. So let's use the Pythagorean theorem. So we know that the hypotenuse squared equals the sum of the two sides squared. So when we solve for the y velocity, we get the square root of 3 meters per second, or approximately 1.73 meters per second. And this is how you approach the problem. It is dealing with these vectors and adding them in the way that the problem is asking you to do. So make sure to practice these problems. And thank you for watching, and see you for the next video. I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what physics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you're a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website at www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online, or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.